Hey folks, how are we doing? It is now day 2 of WWDC. Hopefully you can all hear me nice and clearly and see my screen nice and clearly. Um, Today's talk is about Swift 5.5 and what is new in Swift 5.5. And there's a lot new in Swift 5.5 is the answer. And obviously, concurrency, asynchronous functions, and many more things kind of steal the limelight. They're pretty massive. In fact, they're absolutely massive, and that's fine. I would say this release is easily the biggest since Swift 3. I mean, Swift 5.1 was huge, right? That's property wrappers and DSLs and more and stuff. But this is bigger. I mean, this is a huge release, and honestly, you could argue this is the biggest release since Swift 1. It's just huge, and so. A lot's changing, and that's hard. It's made extra hard because some of the things that are changing, in fact, quite a few of the things that are changing, are really big in their own right, and they're complex. And there's actually an old joke, a brilliant old joke, which is someone says to themselves, I've got a problem. I know I'll use regular expressions to solve the problem, and now they have two problems. And there's a very famous variant of that, which is that if you've got a problem and think to yourself, I'm going to use concurrency so I can solve this problem in parallel, now two you problems have. Of course, the answer there is that it's easy to find your code running at different speeds and different times and completing at different speeds and times. And it just causes all sorts of complexity. We call these usually race conditions when they are bugs. And that's when two pieces of our code are sort of racing to complete the work at the same time and modifying data at the same time. And whichever one completes first affects the result of the program. And they're particularly fiendish to debug, right? Because you've got to try and you run it and it goes, well, it works fine now. Run it again, now it's broken. Run it again, it works. Run it again, it's broken, depending on how fast it all comes back. So it's complicated. And so our brains are struggling a little bit, right? Because our brains kind of don't think in parallel. They think very much in one simple, straightforward line, and trying to think about many operations at the same time is challenging. And just for fun, of course, all this happens attached to WWDC. And so many of Apple's APIs have been updated, either automatically or by hand, to take advantage of these things, these new features. And so you've got lots of change, you've got difficult topics, you've got API churn at the same time. There's lots and lots happening. And so I want to make it really clear, if you're sitting there thinking, wow, this is really hard to understand, honestly, I think that's a sign your brain is working correctly, because it is hard to understand, right? And in this stream, I want to share with you what I've figured out so far. But keep in mind, this is hard for me too. You know, I'm saying this all up front because I want to try and set the tone for this stream. I'm not sitting here trying to tell you the one true way to use Async Await or use tasks and task groups, whatever. I want to hear your feedback and hear your discoveries and hear what you think along the way, and we'll figure it out together. That's where we're at. It's only Tuesday of WBC week, right? And that's okay. We'll figure it out together. You're in the chat. You can't see it, but I'm reading your chat area on my screen down here. I'm seeing what you're writing as we go. One thing we don't yet know is the back deployment story. You know, we don't know what's going to be right now. So right now, it's only available on macOS Monterey plus iOS 15 to have all these new features. And Ted Kremenek on the Developer Tools Swift Lounge right now, like a few minutes ago, said they are looking into ways to find some kind of back deployment story without compromising future performance. They don't know either, and that's okay. They're figuring it out too. And so if you want to support before iOS 15, you might have some problems that we don't know what the answer is just yet, and that's fine. So we'll see is the answer. Okay, let's kick off with some examples of stuff, because so much has changed. And if you've read my existing writing, I'm sorry you'll find this whole stream very, very boring. If you haven't, this will all be new and exciting to you. So let's just dive in together. The biggest thing for end users like us, the most immediate, obvious win, I think, is going to be Async Await support. And this is kind of a foundational thing from our perspective, not so much from the internal Swift perspective, but from the way we use it. Async Await is really, really important and as a way to structure our code. And you'll see this if you've seen it in C# or JavaScript or other languages that have Async Await already. It works very, very similarly from our perspective. And it has the same positives and the same negatives, which is great because if you've used those other languages, you've got a head start already. And this allows us very easily to run complex asynchronous code as if it were synchronous, almost. There's a few little tweaks you got to make here and there. You don't want to get this plague of async everywhere, but it's almost the same, which is really nice. And it's mostly backed by these two keywords, async and await. We mark a function as being async. This must be run in an asynchronous context, not on the main thread. And then we call those using await. So the function itself is async. We call them using await, and that's how it works. And I think the way I've talked about this elsewhere is to walk folks through how code looks right now, like before async await. So 5.4, how would we solve these problems? How would we say, I want to call a function and get a value back at some point in the future without causing my whole UI to freeze up? And we do this using, traditionally, completion handlers, which are closures. And we might say, for example, that we want to go ahead and fetch some data about the weather somewhere in the world. So we'd say func fetch weather history. Now this thing is going to do some work. It's going to connect to the internet and download stuff and parse it. And I don't know what's going to do. Stuff, right? We don't want to say this is going to download and return immediately an array of doubles. We wouldn't do that because it would cause our whole app to freeze while we were doing that. So it's a real mess. Instead, we use completion handlers. We would say that fetch weather history accepts one parameter, its completion handler, and this thing is a closure, a function to run at some point in the future. If it's immediately, pass it on in. If it isn't immediately, we want to say it's going to be escaping. It'll be run at some point after the function ends. In this case, the function we expect to call will take an array of doubles, like that, and it will return void. So we'll call this thing with a function, and that function will accept an array of doubles and return void, like that. Now you'd go ahead and do your complex networking work. Go ahead and download stuff, parse stuff, whatever you want to. Do stuff now on the internet. Could take, a split second, could take minutes, we don't know. It takes time. So you'd put in here your complex networking code. And at some point in the future, call the completion handler. You would say, in our case, we'll just cheat. We'll do dispatch queue.main.async. That's our complex networking code right there. I'll invent some numbers. I'll say our results are 1 through 100,000 map underscore in double.random in -10 ... 30. So we'll get back an array of 100,000 doubles in the range -10 to 30. And then we'll call the completion handler with those values. That's how it works right now. Go ahead and asynchronously do some work, call completion handler with that value to pass it back. We might have some more work. We might say, okay, at some point we'll get some values back from our weather history. I want to calculate the average temperature for those records. An array of double again. Again with a completion handler. This will take some time to happen here. Don't block the main thread. Do it somewhere else. So we'd say this is going to be another escaping closure. Completion escaping closure like that. Escaping. Accept a single double, the average temperature, and again returns void. Inside there, we're going to go ahead and again do our work later on. I'll push this to a background thread, for example. We might say our total value is going to be all our records reduce 0 plus. So add up all the doubles in our array to make one total double. Then get average will be, oh, my dogs have arrived, sorry. total divided by the double of records.count. So that's now the mean average of our records array, and then call the completion handler with that average. So we've got two functions now, both taking a completion handler. And finally, we've fetched it. We've got the average stuff behind here. We'll now upload that average to our server. We'll say something like func upload. Come on up then. Come on up. Say hello to the people watching. Here you go. Oops. That's for later, perhaps. There you go. I wouldn't say no to you, would I? No. Okay. Only one dog. I have two dogs, promise. 2 dogs, 2 straws, 2 kids. Anyway. Upload to our server. So we'll say upload that result double. Again, with a completion at escaping. Takes a string. What did the server return? Returns void. Like that. We'll have more complex networking code here, right? In our case, we'll just do a little cheat. We'll do dispatch queue dot global dot async completion. Okay, like that. Where's the other dog gone? Only one dog. Anyway, so we've got these 3 functions. Fetch some data from the internet. In our case, just generate 100,000 random values. Get the average of those temperatures. Takes some time, so again, it's done by a completion handler. And then upload the results to a server and return back what the server replied with. In our case, it'll always be okay. Now, how would we call that? How would we actually run that functionality here? It would look like this. We'd say, first, I want to fetch the weather history. And when that returns, give me the records coming in my completion handler closure. Then calculate the average temperature for those records. Again, another closure coming in with our average. Inside there, we'll do upload that result with the response coming in. And then finally, we can say print server applied response, like that. So that's roughly how it looks when we have our code using the old school completion handler approach. It's been standard in Swift 5.4 and earlier. Hopefully, you can see the problems with this kind of code, right? It's pretty messy. It is entirely possible for these functions here to forget to call the completion handler. I might have had an if check in here somewhere and only had the completion called in one of those 2 places. So it's called here but not there, in which case the whole thing kind of falls flat. It's also possible to call it twice. Maybe I've had completion here and completion there, you know, a classic sort of go-to fail error from the old SSL days, right? Having things called twice by accident cause massive problems. This kind of syntax, at escaping array of double returns void, this can be quite hard on your eyes to read. There's lots and lots of stuff going on. It's not pleasant to read. And it's actually quite a bit of a, you know, for complex functions like that, it's pretty intense, in fact, I'd say. And then particularly, when we call this stuff down at the bottom, we have fetch weather history, then calculate average temperature, you can see we have this whole pyramid going on. Do A, indent, do B, indent, do C, each one handling the completion handler inside the first thing again and again and again. So there's lots of work happening here. But also think about how it handle errors. You had 2 treats. That's enough for you. You don't need more than 2 treats. Go on. Skedaddle. Sorry, they're obviously never fed. Right, here's the last one. I'll throw it that way. Okay, look. Here, go on. Skedaddle. Right. Got a minute to talk. Gert asks why I use an underscore to help my eyes read big numbers. I'm that simple. Anyway, that's how it looks. How do we handle errors? Well, we might say actually our completion closure might take a result of double, but also some kind of network error or similar there, then handle that in the completion closure down there. It's more complex. It gets more and more difficult as we handle it. And it's problematic. We've got to have all sorts of custom code to handle errors, and indents are messy and escapings everywhere. It's complex. And this is where async await comes in. it can do so much better because we can ditch the completion closures entirely and instead return values directly, as if it were a synchronous function. So I might say that fetch weather history, I'll just delete this whole completion closure part here and say this thing is now an asynchronous function and directly returns an array of double, like that. And then inside the function, I'll ditch the call to dispatch queue main async and just call our code directly. I'll just do that. That's our entire function now. Here's the other dog. You've had no treats yet. Come on. You've had like 3 treats now. Come on. That's about your tubby. Clear off. Enough. Sorry. That becomes our new function. Send the value back directly. No more futzing around, doing asynchronous here, there, and ever. It's already asynchronous. Just go ahead and carry on being asynchronous. Now, when it comes to our average temperature, again, we want to keep this thing coming in. Here's the values to work with. I'll get rid of the completion closure. That goes away. And again, say this is an asynchronous function and returns a single double, the average temperature we want to work with. I'll then get rid of the asynchronous work. It's already asynchronous. Now I'll just do directly return average, like a regular synchronous function would do. These look like synchronous functions. Obviously, the async keyword's there. Otherwise, they look like synchronous functions. And then for upload down here, it's exactly the same thing again. Get rid of the completion closure here. Make it have a string going back. And then just send back. In our case, it is just OK. Like that. OK. So we've removed stacks of syntax, stacks of complexity just from our function definitions, which is amazing. But at the core site, it's even better because we can now start to make this whole thing look nicer. We could say, if I have a func process weather function here that is async, I now go ahead and call those functions one by one in a straight line. I'll just do let records equals await fetch weather history. Then let average equals await calculate average temperature for records. And then let response equals await upload that result average. And finally print server replied response, like that. That's how it looks in an async world. I'm missing async here. Good spot. Thank you very much, Khan. There we go. And Vitor. Thanks for the chat, folks. You can't see it, but the chat window right here hidden on my screen. I'm sort of reading from carefully when I can. And that's how it looks. So all the completion closures, all the indenting is gone. Instead, we have straight line code, we call it, because literally a nice, beautiful straight line. Apart from the await calls that are in there, it looks just like synchronous code. It looks and works just like it. It's absolutely brilliant in terms of understanding. And what we're seeing here is when we're seeing, look, dog, you've had multiple treats. You've got to go away now. Away. You get fed. You really do. What we're seeing here, we're telling Swift, hey, this bit of work, this might take some time. It might take some time. It might return immediate, in which case it won't take any time. It'd be like a regular synchronous function call, but it might take some time. And so Swift has the option to suspend our work, to suspend the function and say, okay, I'll use the thread you on to do some other work instead for a while. I'm sorry, my dogs are extremely love hungry today, apparently. Getting no more treats. It can say, okay, I'll just pause here for a while, suspend the thread, do some other more interesting work in the meantime that's more important right now, and then come back to you later on. And it'll happen here, and then here, and here. They're all suspension points. It can say at any point of these things, yes, go ahead and do some other work. Stacey, it's not actually a late hour for me. You see my clock is 2:20. My brain is currently on Pacific time. Which I find much easier to handle WWDC with. So these are maybe suspension points when work might stop temporarily and come back later on. We don't know, but in this case, it's just beautiful, clear, simplified code. Now there are a handful of rules around doing this stuff. You'll see I've marked process weather as being itself an async function, because If I remove that, I've now got a synchronous function, and this synchronous function is trying to call asynchronous functions, and you can see it's very unhappy. It does not like that one at all, because synchronous functions cannot just call asynchronous functions. It wouldn't make sense. You know, they don't understand how to suspend their work, how to yield their thread back up to the system to do something else with. Asynchronous functions do. They've got a slightly more expensive way of calling themselves to handle this ability to suspend themselves. However, when it is async, it can now call other async functions just fine. Async can call async. An async function can also call synchronous functions just fine. The fact that you're in asynchronous context doesn't really matter. You can call synchronous functions as much as you want to, because broadly you're still in that asynchronous context. And helpfully, and this is very, very clever from the Swift team, they've got some very good handling of functions with the same or similar signatures. And so if you have a library right now, which does a particular way of working, and they want to support an async version of the same function, they can have the same function name in there marked async. So the function has the same signature almost, except one's sync and one's async. And Swift will automatically choose the async one if you're calling from an async context. Otherwise, it'll call the synchronous one from a synchronous context, which is brilliant because you'll see other languages and frameworks have async literally in their function names to distinguish from synchronous versions of the same function. And Swift doesn't have that, which is really, really nice. So that's a great job there from the team, which is great. Now, what I found is that Async Await, the way it works, is so similar, and it fits really well alongside do, try, and catch. I mean, it is so similar in the way it works. Like you can say try, some throwing thing, some throwing thing, some throwing thing in one line of code, and that one try handles it. The same is true for await. And you can actually have try and await or throws and async in the same code, handle it all together and resolve those behaviors as you need, whenever you need, which is really, really nice. There is one catch which you need to be aware of, and it'll blindside you at first, but when you're used to it, it's fine. The order of these keywords is reversed, which is cool. And I want to demo this with some more code, of course, because it's obviously a code-driven event. Let's say, let's get rid of this code here. Question Fuzzy Herbivore, how do you start the async context? That's a good question. And there are two ways of doing it. One is if you're using the new @main attribute, you could say something like, hello.swift here. If you had @main struct my main thing with static func main async, that already works. So you can go ahead and call async functions there, and it'll be run. Expect declaration, is there? Anyway, you can call your async functions there just fine. That works brilliantly. And it'll just boot up that when your app launches out of the box, which is cool. I believe there is work afoot, but I bet it's not in beta 1, to allow async function calls directly at the top level. So in theory, if it's in here in beta 1, I don't think it is. In theory, if I had, again, main.swift, in theory, that would work. No. So I believe in future betas, that might work. We're going to see. Yeah. But later on, I'll walk you through examples of this with actual iOS 15 code using this directly inside, say, Swift UI, because that already has support for this built in. Because like I said, API is changing, Swift's changing all at once. It's just brilliant. Another example. Let's do another example. Throwing stuff. So if we had an example down here of some kind of error loading users, I'll do error here, and then you've asked for too many, invalid count, and data too long, too much information going on. If you wanted to have a way to fetch some number of users, I'll do func fetch users count int async throws returns string. So you can see here, this thing, oops daisy, this thing is an asynchronous function. In theory, I've just collapsed it by accident. There we go. It's an asynchronous function, and it will potentially throw errors. Now, remember, both these things mean maybe. It doesn't actually mean it has to throw errors. Doesn't mean it's actually going to suspend the function. Just means that it can do these things. Inside here, we're going to say if they've asked for more than 3, we don't have that many users. We'll just throw user error dot invalid count. And then if we're still here, we're going to send back as many users as we can. So we will once check says use async to run the context. No, please don't. Don't. I'll explain more on that later on. This is really fluid stuff, folks. It's changing very, very quickly, and yeah, please don't. In fact, I'll show you why not. Where's Safari? Here's Safari. You can go and read. This is the Swift source code repo on GitHub. If you dig into standard library and then look at the public stuff here and then concurrency, you'll find there's a whole section of source compatibility shims to help people bridge their code from old code to new code. And you'll find in here, func async is here, and it's already deprecated. So things are extremely fluid right now, and that async function is used in various WWDC videos, and it seems to be replaced by the new task initializer I'll show you later on. That might still change. You know, they've got a really good, open, flexible approach with these things because so much is changing that they really, really do want community feedback. And so, you know, get onto the forums. You'll see Ben Cohen's posted a thing there saying, what's your feedback on this concurrency stuff? Let us know how you're finding it. And they want to hear your feedback. So, you know, get in touch and get involved. Anyway, work. Yes. Here we are again. So, if we've got more than 3 requested users, just say we can't handle it. Sorry. If we're still here, we'll send back an array. And I'll pass back. We have Anthony. We have Karamo, and we have Tan, and I'll just use prefix up to count. So that's what 1 they'll get back Anthony, get back 2 they'll get Anthony Karamo, and then Anthony Karamo Tan if you have 3. That's our simple fetch users method, but it can throw errors. That's the main thing. And then we'll have another one. We'll do func save those users a string array. Again, it's going to be async, and again it's going to throw and return a string. We'll do let's save users equals users. Dot joined, separator, a comma, and if that is too long, save users dot count over 32 will throw another error. User error, but data too long. Else, you know, actual saving code here, and return saved users. Okay, so 2 very, very simple functions to get some data and write it out somehow, but they're both marked async and throws. They are asynchronous functions. They must be called from an asynchronous context, and they might throw errors. Neither of these things, by the way, are doing any asynchronous work, right? Async means, you know, they have the potential to suspend. In this case, they are not. When it comes to calling these things, though, this is where it gets problematic. Krish, what does prefix do? It returns the first n number of items. So if you do prefix 1, it returns Anthony, prefix 2, Anthony, Karamo, and so forth. Anyway, down here, we're going to say there's a func called update users, which is async. Inside there's our do block, and we'll get our users by saying try await fetch users count some number. I'll do 3. And let result equals try await save those users. And then print the result. Anything that goes wrong, we'll catch and print out oops. So, this is what I'm saying about the order being reversed. It will real curveball at first, but it makes sense eventually. We have at the function definition level, the function's type is async throws. It is asynchronous, it might throw errors. But when we call it, it's try await. It's the other way around. Attempt to call this thing and then wait for it to complete. This went through extensive review, as you might imagine, on the evolution system. And I think it's fair to say they're right that try await does read off the tongue more easily than await try, which is great. But more importantly, I think it reflects what's actually happening here. We are waiting for some work to complete. Await fetching this thing. And if it does complete with an error, then throw it, as opposed to the other way around. So, That's the basis of Async Await, and you're going to find it all over the place in iOS 15. They've adapted it in lots of places. For example, URL session. If you had some function down here, let's say we had func fetch data here, you might say, I want to use URL session. I want to try and read some value out. Khan says, do you get an error if you use await try? It used to be a warning, but I'm not sure what happens in beta 1. Beta 1, it is still a warning. Yeah, it's saying don't do that. So yeah, try await. Don't get it the wrong way around. And that's actually, it was an explicit choice from the developers, let's make this enforced. Let's not allow either way around. Because they could have let it go either way. It doesn't really matter to them. But I think having a simple, strict way of thinking actually removes problems. Anyway, URL session and many other types inside the system, Foundation and beyond, have been updated to support Async Await. For example, you can now say, let URL equal some kind of URL. I'll do https:// apple.com, like that. And then I'll do data underscore is try await URL session dot data or shared, dot data from that URL. And that's it there. That'll go off and fetch the data as it needs to be. I have to put this in an async context by accident. There we go. And attempt to handle that, fetch it, from the server. Go ahead and fetch all at apple.com, download it somehow into this data, and then parse it, save it, whatever you want to handle along the way. Let's just put an exclamation mark in there for now. Boom. So you can see it's that easy now to do these kinds of things. You can just say, go ahead and fetch stuff and figure it out. There's no more, it was data response error. Is there an error? Is there a data? It's very, very confusing and messy. That's all gone away. And yesterday I walked through an example of this inside SwiftUI. Carl, what does it mean when I say in context? So you've got to imagine your codes could either be running currently on the main thread where all your UI work happens. It's a very privileged position there running with. And it's that is a synchronous context. Everything runs sequentially one after the other, right? In an async context, we have the possibility of running in parallel. Doesn't mean it is running in parallel, they're different things, but it means it has a possibility of running in parallel. And so we want to keep that separate from our main piece of work. These bits here might be able to run in parallel. These bits here definitely are sequential. And so there's an async context and a synchronous context. I want to walk you through an example of this using the refreshable. I taught this yesterday. I'll do it again now because it's so awesome. And this is in SwiftUI for iOS 15. You can now ask system to have pull to refresh functionality inside your UIs. And it's so very, very nice to do because it's built using Async Await. And so if we had our simple UI here, I've got, text, hello world, whatever. If I had a navigation view here, and then a list inside this with 1 to 100, row in, and then text, row. Pavel, an error, macOS. Oh yes, you're probably right, Pavel. You're probably exactly right. I was using the new URL session code in macOS 11, not macOS 12. I don't risk Monterey. I'm sure it's brilliant, but I'm doing streaming. I don't risk that catching fire, even worse than it is right now. Anyway, there's a SwiftUI list of stuff, and in theory, I can press play and see it previewed on the right-hand side here. Xcode has been causing some comedy audio problems for me recently, and hopefully that's not going to come back. I know it's beta 1. I don't blame them too much, but we'll see imminently whether I have any comedy audio problems or not, while it's busy preparing the iPhone simulator for previews. I need one of those fancy pants M1, M2, whatever it is, iMac Pro. But I haven't got one of those yet. I've got my old Intel i9, I think it is. So sadly, I have to wait for my Mac to catch up with my brain. Come on, Mac, you can do it. Show me a preview, please. All right. While it's thinking about its crimes, I'm going to just carry on and say that, oh, there we go. Thanks for that. See, I was threatening you. Launch straight away. You can see a bunch of rows there, which is fine, exactly how you expect it to be. I might want to say this thing has pull to refresh. And you do that by now attaching a refreshable modifier to your view hierarchy somewhere, and then do some work. Yes, great. I said it is the popping noise when the simulator is running. It's spread now to Xcode, which is great. Oh, brilliant question from Marco Pont. Hi, Mark. I hope you're doing well. Hope the kids are good. Is there a reason why async is afterwards as opposed to preceding the func keyword? This is a brilliant question because it tells you a lot about how the way Swift works internally. Because functions are types in Swift. They're a type all by themselves. And as a function has a type, what is the type of the function? What values does it accept? What does it return? Are both parts of that function signature. Not part of the type are things like, I believe, how visible it is. Is it private or public, for example? That's not part of the type. But is it throwing or not is part of the type. And async is also part of the function's type. It is an asynchronous function. And so having it at the end as part of the function type itself makes more sense than stashing it somewhere else, because it is literally part of the function itself as opposed to a modifier for the function. It's part of the function. It describes it. And so you have a parameter that expects to be given an async function. You mark that right there as part of the closure. You'd have something like, open, close, async, throws, void, or something like that, right? In your parameter type. Anyway, sorry, massive tangent. In here, refreshable. Once you have refreshable in here, you can say something like, print, do your refresh work here. Boom. And that's what it takes. That's what it takes to get pull to refresh working inside Swift UI. You now just drag down from the top, and it will call this function immediately and refresh the UI. And if you scan into what refreshable's actually doing, if you look at the definition inside Swift UI, I'll drink some coffee while it's thinking in slow motion. Boom. So you can see this thing here expects to be given, again, right there, baked into the function's type, expects to be given an asynchronous closure it can run. And it'll go ahead and run this thing for us, which is amazing, because what happens here is it will, as you pull down, it'll reveal a bit of the indicator. I'll press Command R. Let's see if it's going to break my audio or not. If the audio breaks, I apologize. You'll have to wait, and if it all goes wrong, we'll just do it again tomorrow. Because I'm not responsible for Xcode's audio breaking, I'm afraid. So we'll see how we get on. While it's loading in slow motion, it's a standard pull to refresh indicator. You sort of pull down, sort of see a bit of the clock appear, pull further, more clock appears, pull all the way, it starts spinning on the screen. It'll then call the refreshable closure. This function here, print do your refresh work here, and it will wait for that to finish. And as soon as it finishes, it will then go back and hide the little clock refreshing indicator. So it knows how to wait for the work to complete, which is so important, and it's expressed just beautifully here with a very small amount of work. Here is my simulator, and if you now hear crackling sound in the microphone, I'm sorry. It's nothing to do with me. I'm doing my best here, folks. Justin asks, what about scroll view? Does refreshable work there too? Honestly, it ought to, but it does not right now. And so either that's a bug, or it's a feature, and it will never work, or at least not until iOS 16. But right now, it only seems to work with lists. I would say, by the way, this is quite a clever feature. Refreshable, the fact that it just works out of the box. Has it finished? No. It's just, sorry, Mac is so very slow. The fact that it works out of the box is brilliant because we know we're in an async context. We can go ahead and start calling await, 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 await inside here to do more complex work. Now, here we go. So I can pull down here. And if I pull, get a bit of the clock face, and I release, boom, do your refresh work here appears, but only when I fully pull the thing all the way down like that. So that's a simple way of doing it. Obviously, in a real example, you want actual work happening here. And this is where you can use the new URL session async await values too. And I gave a complex example yesterday. I'll do it again here because it's helpful to see it really happening in real life. I said there's a struct called news item, which is decodable, news item. Decodable is going to be loaded from JSON and also identifiable, so it can be shown inside a SwiftUI loop. I'll do let ID int to satisfy identifiable, and a title string. Come on, Hudson, you can type properly. Title string and a strap string. And inside content view, I'll say by default there is one news item, private var news equals an array of news item, and I'm going to use ID 0 title want the latest news. Oops, latest even news strap pull to refresh. Like that. So by default, you see one item in there, and inside our SwiftUI view, rather than just looping over 1 to 100, we can now say, actually, I want to have a list of all my news items with each item coming in. And for each item, I want to have a VStack alignment being leading. And first, I'll have the item's title in a nice headline font. Then item strap line. Item, come on, you can do it. Item strap. My Mac is really not doing well for speed right now. Foreground color secondary. There we go. Like that. So go ahead and show our items in a VStack inside the list of stuff. Now, inside our refreshable, we want to do some actual work now. Do some real async await work. We're already in async context, which means we can call await functionality here. I could say do start a throwing block of code, and then make a URL. In our case, the URL is going to be the string of https:// www.hackingwithswift.com/sample/news1.json. That ought to be, if I haven't made some comedy typos, an actual URL pointing at some JSON. I can now fetch it. I can say let data underscore. The underscore here is the URL, the HTTP response. I don't care about it here. I just want the data. So I'll do try await URL session.shared.data. Again, using the data from option. That URL. So go and fetch it, download it, put it into data for us to work with. I can now decode it. I can say news equals a JSON decoder dot decode an array of news item dot self from that data. And now what I'll do is catch any errors down here. So I'll say if anything goes wrong in the decoding, get some nonsense, for example, or we can't get to the internet, whatever, news will be an empty array. And I've made an error here. It's saying, well, yep, try. That's important. We try. And in theory, that should compile and run. Let's find out. Press Command R to launch that code. Come on, Matt, you can do it. So, one minute news, pull to refresh. I'll just pull down and release, and boing, in it comes. So it's done all the work of fetching it and playing it back and decoding it on the screen immediately with hardly any code, all asynchronously. I haven't had to worry about dispatch queue, main, async, whatever nonsense. The old URL session APIs, not needed anymore. This is a much nicer way of thinking, much nicer way of working, much less code for a start. It's a big improvement. So that's how we have async await in, simple example code. So you can see the basis of how it works and the improvements you get, but also how you use it inside real applications now with iOS 15's improved APIs, which is great. Now, you might think this is the death knell for the result type, which was introduced in Swift 5. So we could say result success, array of news items, or result failure, some kind of error happened here. And that's partly true, mostly true, maybe I'd even say. Certainly they knew at the time the benefit of result would decrease when async await hit the language. They knew it'd be less important because, there are other things to worry about, right? But it's still useful. Result is still useful because it's still the best way to store the actual resulting value of some functionality. Stash it away in the result, pass it around elsewhere evaluate that in a few minutes or later on, whenever you want to, at some point, which you still can't do with this kind of async await stuff. Results much, much better at that, storing the actual finished result of value and just passing it around. Now, as you've seen in our code, I was always wrapping things in async functions like this. So async function calls async function calls other async function, and so forth. Good night, fuzzy herbivore. And that's how it works, quite frankly. You know, async functions call other async functions. That's how they work. And in a pure Swift approach, you might wonder, well, how the heck do I start doing an async function? How do I start from synchronous calling asynchronous? I gave you an example here because SwiftUI is doing it for us with Refreshable. But in your own code, there's a whole other batch of ways of doing that. And it's part of a separate evolution proposal, structured concurrency. Oh, someone's hit a dislike. I'm trying my best, folks. Sorry for doing these free live streams. I am doing my best. So you might think there's no way of doing launching your first async function, but there is. It's part of the proposal, and we'll get onto that shortly. And the other thing you want to think about is, and this is very important, no part of our code over here, our basic example code, is designed to run in parallel, right? This is all asynchronous, but not parallel. It's concurrent, and they're different things. And the way to think about it is like a single core CPU. Like, you know, Intel Core Solo, remember those from like the original iMacs or Intel? And they had a single core, right? But they could still run Mac OS X and play music and surf the web and even though they had a single core. Now, at any given time, it wasn't doing two things at once. It wasn't running the network and Safari and whatever, you know, not Spotify, but whatever it was at the time. Napster, I remember, a long time ago. It wasn't doing those simultaneously. It wasn't running them in parallel. But it was able to handle concurrency. It's able to pause this thing and do some other work for a while, then pause that thing and do some other work for a while. So we're distinguishing between being able to run things together and actually running them together. They're different things. Anyway, that is our first proposal, kind of flown through really, really fast. Next up, I want to talk to you about another important change, which is effectful read-only properties. And this is a much more advanced way of handling properties now, because properties, if they're just computed reading properties, can be throwing and asynchronous now. You can be, you know, get, throws, async, all in one big mix of functionality, which allows for a lot more power. And you'll see this comes back later on in some of our code. Now, as an example, I'll go back to our simple example function over here again. Let's delete some of this code. We could say I want to have a way to load bundle data. So I've got my app bundle here, and there are files inside there. I want to just yoink it out and use it. And we might say first up, well, there's an enum for all the possible file errors we can have, which in our case, there'll be two of them. The file isn't there, it's just flat out missing, or it's unreadable. Like, it's there, but it's, you know, locked or corrupted or no permissions or who knows what, right? So it either isn't there or it is there, but we somehow can't read it. And now inside, I'll make a new struct called bundle file. I'll say, you make this thing by saying, what's the name of the file you want to read? So file name is a string. And then we can read the contents of that file as a property. Now this thing isn't going to be writable. You can't write back to your app bundle. It's read-only. It's fixed in time. The only changes when you download updates from the App Store. Sam, I am reading the chat. Hello, Sam. You can't see it. There's a chat window on my screen over the Xcode thing. My software is very clever. It kind of hides it from you. I am seeing it. Yes. Hello, Sam. Anyway, we want to read our file, but it can't be written to. And so it's going to be a read-only property. It's got a getter inside there to compute the value as we go. But this thing might take time. It could be a huge file. So it takes time to figure it out and load it and yada, yada, yada. So I'll say not only is it a read-only thing, it's also asynchronously read-only. Plus, again, the file might not be there. The file might be unreadable. So it's not only getter and asynchronous, it's also throwing. It's a getAsync throws property. And now inside here, we can say things like get me the URL by using bundle.main.url for resource, our file name, extension nil. If that fails, we'll do throw file error dot missing. Heidi, you don't need a sneaky way to get a shout out. Hi Heidi. Get the URL. If it fails, throw a missing problem. And then do a do block. Attempt to return the string version of that file. If that fails, I'll throw file error dot unreadable. We literally can't read the file, even though it exists. So now we have this struct with a property content, which is async and throws at the same time. And because it's async and throws, we've got to use try and await to read that value coming out again. So I'll say down here is a new function called print high scores, which is async and throws. I'll do let file equals a bundle file using the file name of high scores. And then try await print file.contents. So attempt to read the file's contents, print out the result, and then also wait for it to finish. It could be asynchronous happening at the same time. Now, cunningly, just like with try by itself, you can shuffle these around if you want. You could say print try await file contents if you prefer to. It doesn't really matter. What I would say is that, I said it earlier, repeat it here perhaps, these things stack up beautifully. And so, you know, if you had try some throwing thing, dot some throwing thing, dot some throwing thing, whatever, which you can do right now, you'd have one try. The same's true of await. One await will await for many, many things here. Cooper, that's not really fair to say. Chris is a wonderfully nice man. He wouldn't do that. He's a good friend. So now we have these complicated throwing properties, which is great. And they're used elsewhere, as you're going to see shortly, because this is sort of another one of those foundational blocks that Swift builds upon to do more advanced things. It calls them effectful read-only properties, and they're very, very powerful indeed. So let's go on to sort of the main event, or one of the main events, as it were, the next level up. How we actually handle concurrency. How do we execute tasks together, cancel tasks, monitor tasks, and so forth. How do we handle this? And this builds upon async await. It builds upon these effectful throwing properties and similar. Effectful read-only properties, sorry. It's kind of building up a hierarchy of information here, so from simpler to more complex, which is great. Now, this is part of a proposal called structured concurrency. It's actually technically still in review. I asked literally like an hour ago, has it been approved yet? And the answer was no, it's still being revised and improved and refined. Even though it was finished a little while ago, which is great, because it means you still have time to go and weigh in and see what you think. And you'll have seen this demoed at WWDC videos, weirdly with the old syntax rather than new syntax, which isn't ideal, because it's evolving quickly, but that's fine. That's why it's part of the fun, right? And so I'll try and walk you through what is the current correct syntax for these things, but it may at any point just go away and be replaced. Now, this is going to require some more functions to work with, like fetching weather data and calculating average and so forth. So I'll give you some examples I have to work with. First, we'll say that we have a way to fetch some weather readings. So I'll say there's an enum called location error, which is an error, and this thing has one value, which is unknown. I don't know what the weather readings are for that location, because I don't know what the location actually is. And I say func get weather readings for location string, async throws, returns an array of double. Inside here, I'll do switch on the location. If we've been asked for London's weather, we'll return lots of values, so 100 values, 100 even, map, and approximately in normal temperatures, it's going to be double.random in 6 through 26. Like that. Then I'll copy and paste a few times. And we have case Rome. Again, 100 values. The values here are going to be between 10 and 32. And then we'll have also San Francisco. Here it's like 12 to 20. So, you know, quite nice basically. And default all other values, I will throw location error dot unknown. So no idea what it is, just bail out and throw an error. That's our first function we're going to be working with. A second one is a simple synchronous way of getting the nth number in the Fibonacci sequence. So I'll say func Fibonacci of number int returns an int. Our first is 0, our second is 1 for underscore in 0 to number. Let previous equals first, first equals second, second equals previous plus first, and then finally return first. That's the Fibonacci sequence in a few lines of code, right? That's it right there. Now, the simplest async approach used by structured concurrency, I showed it briefly earlier. This is where you use the @main attribute to launch some code asynchronously. This does not work in a main.swift file. That auto-generates the main for you. You've got to call it something else like my app.swift, for example. And now you can say @main struct main static func main async throws. And this will automatically be run when your program starts up in an async context. You can go ahead and call stuff from here. So I might say my readings is try await get weather readings for London. And then print readings are readings like that. And that works great today, right? You can do that now with @main. That's the simplest way to be working along with your program. Obviously, it doesn't cover many cases unless you're making many command line apps, but in theory, that's the easiest way of doing it. Like I said, I believe it's also been possible in the future to remove this and have top-level code being asynchronous, and it'll basically wrap it in a task automatically. It doesn't actually work yet, but I presume it's coming. I think I last saw John McCall talking about that on the forums. So we'll see, is the answer. Anyway, that's the simplest way. But realistically, you want to use one of the new structured concurrency types, which are task and task group, for handling things to run concurrent operations individually or in some kind of coordinated way. Shadowfax, can you have Xcode 12.5 and Xcode 13 at the same time? Yes, you can. You can. I have it right now, Xcode 12.5 and Xcode 13 at the same time. I haven't got Monterey. I only have Big Sur. Sorry, mine went for a moment there. Oh, it's Michael Mayer. Oh, I missed you, Michael. Sorry. Thanks for coming on, Michael. He's a good pal. Anyway, so that's the simplest way of doing it, but realistically, you want to have task or task group like this. And this is where we saw async being used at WWDC. And right now, at least, that has been deprecated. And that itself was replacing another deprecated function called spawn. It's been through quite a lot of discussion, which is great, by the way. It's lovely seeing the backwards and forwards discussion, improvement, refinement. Right now, it's done using tasks, the same thing. So when you saw something like async blah at dub, the current approach right now is to do tasks instead. And so let's have a go at doing that. Let's have a go at doing that now. So I'm going to say that inside here, we want to go ahead and make some tasks. So I'll say, get rid of this guff up here and call this thing main.swift again. I'll say the function called print Fibonacci sequence, which is async. And this thing is going to use what was async previously. It's now a task. We'd say let task 1 be a new task, and this task will take no parameters and return an array of integers. Inside there, our numbers will be an empty int array. We'll count from 0 up to 50. Then for each of these things, we'll call Fibonacci of that number and do numbers.append result. And finally, return the numbers. So this whole task here has an empty array of numbers, counts from 0 to 50, gets Fibonacci of that number, adds the array, and then, in there, and adds it to the array, and sends the array back. Now it's complaining because it needs Monterey, I believe. Yes, it wants Monterey at this point, which isn't ideal, but that's the correct syntax. I'll probably futz it with one of the tool chains. Let's try this one. I think it's fractionally more modern. It might still complain that I'm not on Monterey, but, you know, it's all right. Anyway, you'll have a little think about that in the meantime. That's how we get value back. And what happened is task 1 will now, my Mac is now beach balled. I've dared to switch to a different Swift version. Therefore, I get a beach ball. Unbeach ball, there we go. I've now made the task. It's going to go off and do its work to calculate all these results for us in one go. And when it finishes down here, after the task was done, I can say, try and get that value coming back. Now, this is where those effectful read-only properties become really, really useful, because we can say, let result, Xcode's completely beach balling now. Cool. It's thinking at result, there we go, at 1 equals await task1.value. Wait for that effectful read-only property to come back. And that's where it's marked as async, so it'll take some time to come back. And when it's done, this line will finish. Its result will be in result 1 for us to use. In this case, it's an array of integers. So I might say something like print the first 50 numbers are whatever, and then do result 1 like that. So if we've got lots and lots of function calls being put inside this task, running, it'll go away and just do it, right? Now, I've had to be explicit here and say this task takes no values coming in and returns an array that's just coming out again. If you have very simple tasks, that isn't needed, because you can just ditch it entirely and just do the work directly without having to say exactly what it is. In this case, you can probably see at a glance, we're basically going from 0 to 50, calling Fibonacci on each one. And so all this code can come out, and really you can just write 0 to 50 dot map Fibonacci like that to get the same result. And that way I haven't got to say the exact functions type for the task, because it knows. It can read it from here. Now it's whinging because it doesn't like the version. Trust me, that is the current correct syntax for making these tasks. That's how it works. I'll come back to the official toolchain perhaps. I'm expecting beta 2 or maybe beta 3. You'll get this version of the code, or just get a snapshot from the site. Anyway, so that's what we're looking at. Give me this task, go ahead and do the work, and give me the value back using these effectful read-only values here. Wait for it to finish, and then put it into there. Now, what will happen here is, behind the scenes, this task is going to start running straight away. Like, you know, here, the task is gone. It's off, busy doing its work, right? And our code carries on running wherever it was. And as a result, it's going to, over here, do its work, and eventually the await will go, it's ready, and read the value out for us, which is fantastic. Now, what is happening internally to task is we're passing it some work to do as a function, or in this case, a closure of work to do. And the task starts running that work immediately. It doesn't hang around. It goes, right, go, let's do the task, let's get to it, right? As a result, this is a non-escaping closure. It's run immediately, which means if you had one of these things inside a class, you don't have to say self.foo, self.bar, self.baz, because there's no chance of capturing happening here. It's run immediately and discarded. So there's no requirement to have, weak self or similar. Now, when it comes to reading the value back out again, that's where await task1.value kicks in. This will make sure all those calls of Fibonacci finish fully. The whole task finishes fully, and only when the output is ready does it go into the result to read it back out. And this is really powerful. You haven't got to worry about watching it or monitoring yourself. It'll just take care of itself for you. You just say await, and it'll wait for it to finish fully. If you don't care what the task returns, you just want a fire and forget function to run, do its thing and skedaddle, you haven't even got to store the task anywhere. Just use task by itself, and it'll run off and do the work for you. And it'll make sure it finishes before it exits, because that's what it's trying to do here. Now, if there are errors being thrown, you can handle that as well. Why do I look younger? Asked Colin. All the coffee? I have no idea. Coffee ages you, surely. Anyway, if you have multiple things here and maybe some are throwing or errors happening or whatever, you've got to handle it appropriately. This thing will gain extra powers. Right now, it is an async property, but it can also be an async throwing property as well. So we might say, I want to run multiple calculations here. I will do async throws. Again, we'll have our first task. I'll just copy and paste the first task. Let's do this whole thing here. You go into here like that. And the second task is going to be another task with try await get weather readings for run. Throws. There we go. So we've got two tasks happening now, one of which is throwing. And we can now say, let result 2 equals try await task2.value. Wait for it to come back like that, but make sure we try any errors here and handle appropriately. Now, this whole thing is marked as throwing, so it'll just bubble upwards at this point to the next level, which is fine. You can then, at this point, know that both values are back. The first number to this, and print Rome where the readings are result 2, like that. So we've now got 2 pieces of work happening in parallel. We're going to just launch tasks to start running, wait for them both to finish, and then print out their values. Now, I would expect that, I haven't tried it, but I expect if I had this whole thing here in my SwiftUI project, let's paste it into here maybe. I have to steal those methods as well. Where are they? This one, and I think all these functions here perhaps. You can all come in. There we go. This will be, oops, no, enum shouldn't be in there. No, that's fine. This will be slightly closer. There's fewer complaints now because I'm using the iOS 15 SDK. If I switch across to the new tool chain, will that work with iOS 15 SDK? Let's just find out. I don't want to find out, isn't there? Press build. If my Mac beach balls again, you'll just have to wait. Someone asked about dogs. The dogs. Lord Mooch asked about dogs. I think it was. Lord Mooch, I'm sorry, the dogs have been and gone already. They've had their fill of treats. They might, if I make the treat sound, they might. Dogs? No, it's. I don't know what time it is anymore in the UK. What time is it? 10 past 11 in the UK, so they're probably downstairs asleep somewhere. So they are clearly not interested in treats, I'm afraid. So Lord Mooch, you have to miss out on dogs today by the looks of it. It's building this in slow motion. It's probably not terribly happy that I have the iOS 15 SDK backed up by some random Swift main snapshot. I'll let it think about it for a while. Anyway, so we've now got individual tasks being created. Just randomly, unstructured, go ahead and do a task, please. Go ahead and do a task and then wait for it later on when we're ready to wait for it. It's a nice way to handle work being executed in concurrent ways. When you have to customize somewhat, there are lots of options you can add into this. You could say, for example, I want to have different priorities. I want to have a high priority task when you make it. And that's available right there in the task initializer. Oh, bar 3:45 a.m. Respect. Lewis, no, it's not an M1, it's an interline 9. It's like a year old, 18 months? A year old. I've lost track. Time's a blur. 18 months old at this point, and it's aging slowly, that's for sure. Anyway, what was I saying? Priorities, yes. You can make your task with priorities. You could say, I want to have this with various priorities, and you could say high, default, low, or background. And these more or less match up with the traditional sort of Darwin style one we're used to. User initiated is high, utility is low, and then well, you don't get user interactive. That's been blocked away. That's not for us to use anymore. That's main thread only. But you can use either one. You can use the sort of traditional one or use the modern names you prefer. This is not even building with the custom toolchain, so let's not do that. It's a bad idea. You have to stick with my wonky build on the other screen instead. Anyway, just survive with these warnings. They're perfectly fine. They are correct. It's just Xcode being useless. Right. Can I maybe activate the main? One last try. Try that one. It's thinking. It's your last try, Xcode, before I switch back to just carry on coding and talking, which might do best. What do I think about M1? I think they're brilliant. I'd love to get one. I'd love to have an M1 iMac right now, and I don't. I'm annoyed. Anyway, so we have tasks. We have task priorities, which is cool. You have various extra functionality. You could say sleep this task for a while. It's currently measured in nanoseconds, which is basically extraordinarily hard to read because 1 billion nanoseconds is 1 second. So you've got 1,000,000,000,000. I've got a macOS versions now. There's a hack you can put in place, a build setting, which I don't know off the top of my head. You can force that off with a build setting to say, don't warn me about macOS 9999. Let me try and find it real fast in Safari. See if I can just grab it. Oh, come on. The screen. I run on the screen. Rats. Oh, anyway. You can Google it, folks. If you find out whether that option is to disable version availability, let me know and I'll enable it so get rid of the warnings and errors. Anyway, you can sleep your task for X number of nanoseconds. You could say, have I been cancelled or not, using task.checkCancellation. And if you have been cancelled, it'll throw a cancellation error. If it hasn't, your code carries on, so you can avoid doing unnecessary work. You can call task.yield to say, go ahead and do some work elsewhere in the system for a while. If you want to have like a really tight loop, for example, and you don't want to chew through too much CPU time, yield some time elsewhere. Anyway, cancellation matters. Being able to say my work isn't important anymore, or that task isn't needed anymore, whatever. Just bail out, and you can do that using cancellation. So we might say, for example, I have these warnings are really annoying me. You can absolutely do it. There's a way to do it. I don't recall what it is, I'm afraid. So if I had like Swift disable availability checking, blah 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 blah, go away. None of those. Not that. It's a build setting. It's a front end build setting. I'm sure it is. None of these. No. 9999. Sorry, folks. Aha! This sounds good. Concurrency API not available. There we go. That's the one there. I saw it. Oh, bah. Where is it? It's X front end horror show. That's the one. Look at that. Boom. So don't warn me that I'm not on Monterey, is what we're saying. Yes, I know I'm not on Monterey. Please just do it anyway. Build settings. And was it other Swift flags? I think other Swift flags, maybe. Other compiler flags. Let's just search for Swift in here, shall we? Swift. Blah, 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 blah. Other Swift flags. I think it's probably this one here. Let's add that in here and see if that makes it significantly happier. Stop screaming at me, is what I'm trying to say. It's going to sit and think. It's going to sit and think for a good old while. But hopefully that will get rid of the major errors in my code. Because the code's correct. It's just, it's convinced it's not correct, so I'm not on Monterey. Yeah, so it builds fine now. There you go. Okay, so you can now see it's working correctly, which is great. Anyway, next up, so we have cancellation of stuff. Let's say we want to have a task you can cancel. I might say func cancel sleeping task is async. If Paul can Google it live stream, all my insecurities go away. I Google all the time, folks. Often Google my own stuff. I can't remember all in my head. Front-end Swift flags do not stay in my head, I'm afraid. Yeah, anyway. we're going to make a task. We'll say my task is a new task that takes no params and returns a string. And I'll print out the word starting. And then we'll say await task.sleep. And I want to sleep for 1 second. Like I said, this thing is measured in nanoseconds. And so I've got to say 1, 0, 0, 0, 0, 0, 0, 0, 0, 0 to mean 1 second. After the 1 second, I will do try task.check cancellation. Like that. Attempt to see if it's been cancelled or not. And then return done. That's our task. And it'll start running immediately. It'll start go. It's already happening. But we're going to cancel it while it's sleeping. So I'll say task.cancel. Bail out immediately. And now we'll say let result equals try await task.value. And then print, result was result. And then we'll do catch print task was cancelled. So what's going to happen here is when we call task.cancellation, yes, it is static. It's all static, these methods. We say check cancellation. Have I been cancelled or not? And in this case, it will realize, aha, I have been cancelled. It will immediately throw a special cancellation error. Yes, don't do any more work. So it won't return done. It'll bail out saying I was cancelled. But we don't know that because that whole throwing thing is wrapped up inside the task. It only actually throws the error down here where we try and read the value back out from the task. That is the one that's throwing. That's the one we've got to mark with try. And it's super smart here. It understands we've got to mark it with try. It knows this thing is going to throw errors because we have this try line in here. It's going to throw errors, right? And so we know we're going to handle it appropriately and put the right thing in here. And so this will print out, all being well, task was cancelled. Again, not running Monterey. Very much not running Monterey. But let's find out if it's going to run anyway. Because you never know. Have a bit of fun. A bit of a on-screen, on-stage, crashy, like fun times. Let's find out. Waiting to attach in slow motion. Normally this Mac's fairly fast. Obviously, Xcode plus simulator plus live streaming, not so much, but that's all right. I'll get me an M1, M2 Mac Pro one of these days. No, iMac Pro. I can't afford Mac Pros. iMac Pro I can afford, maybe if I'm lucky. It's just thinking. It's not getting anywhere, I'm afraid. But that's how it should work. That's the point of this thing. Okay. Yeah, didn't get anywhere. Yeah, nothing. Oh, I haven't called the function. That's why I haven't called count sleeping task. Let's put in here my main, and then down here, let's call the damn thing. At main, struct main, static func main, async, and then we will call cancel sleeping task. That'll work much better. Always call your functions, folks. Otherwise, it won't do anything. An important life lesson right there. Let's try again. This time, calling the actual function we're supposed to have in the first place. Bang. Yeah, so now it's not happy. It hasn't got libswift concurrency. I think there are hacks again for that you can put in place to try and get the thing working now. Where was that sort of forum thing? Blah, 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 blah. None of these. Probably. No, probably not that one. No. There'll be a way of saying don't load the libraries, which is really, you don't want to do that in production code. But for just noodling around, nah, it's fine. Right, don't run the code unless you're running Monterey. It's going to explode in your face. Anyway, so we can use try await task.value to read the resulting value of the task or handle the error at that point. And if you don't want to handle it just yet, you can instead say let result is task.result. And this thing will give us the result form of the task. And now there's no errors to handle. We haven't got to have do and catch in here because the error still hasn't been looked at. It's still sitting in there. It's like Schrodinger's error. Is there a result value success or is there a failure error in there somewhere? We don't know at this point, but we get to evaluate that later on. So Swift's result type is still really, really useful. You'll see it right here. this thing is useless. Not helpful at all. This thing will be a result string error like that. That's what it'll be if code completion worked in this hacky version I'm running here. That's what it'll be. And so you can pass it around from function to function to function as much as you want to until you're ready to evaluate it, at which point, fine, you can look at it and use it. So these are tasks. Create one, they start running immediately, wait for them to finish, and then respond however you want to. For more advanced work, that's where you start creating task groups. These are collections of tasks that work together to produce a single finished value of some sort. Now, there are lots of careful rules around using task groups, and I think Swift enforces them all for you. Like, it stops you screwing things up. It's really, really good at avoiding problems, which is fantastic because any kind of numpty mistakes I would make, I'm a numpty, it kind of spots and says, no, you can't do that, no, you shouldn't do that, no, smack, don't do that, whatever. It does help you out a great deal. So let's zap some code from here. There's stacks of boring stuff. We'll make a task group. We'll say, I want to print a message. Print a message. This is going to be async. And this thing is going to attempt to make a string. One string. By calling await. Now, what we're going to call is a function called withTaskGroup. And this thing creates a task group of as many tasks as we want. And it will work together to finish them up and send back a single value. In our case, a single string. And one of the many protections Swift puts in place for you is you get access to the task group inside this function. It passes you the new task group. So we'll say await with task group. And this thing is going to build a string. That's its job. It'll give me this, the group coming in, my new task group. Now return a string. And now you can go ahead and give it all the work you want to do. You can say, I want to get a string from the local file system, get a string from the server, get a string from my pal down the road, whatever you want to. You can return strings however you want to. Each particular task inside the group fetch a string where you want to. In our case, we'll just do group.async and do hello directly in there. So there's no fancy code to return hello straight away. And the reason we're doing this is because if I say group.async hello, then group.async from, and then I'll copy and paste a few times, like this, a task group, like that. So I've got 5 tasks inside my group, each one giving a different string coming back. I could then say, I want to collect those into a single value. So I'll say our array is called collected, and it's a string array. I'll then await every value coming back from that using for await value in group. Collected dot, come on, append that value. And we'll end up with this string array of hello from a task group. I can now return collected dot joined separator space. So I'll get back hello from a task group. And after the task group finishes, I'll have a real string. I can do print my string. So, real simple. 5 individual tasks, part of one task group. They all start running straight away. They all start doing their work. Hello from a task group. We then piece them together to a single array and then join it with spaces. That looks great. That looks simple. But in practice, when you run that, you have the problem I mentioned earlier. Now you have 2 problems. You might get hello from a task group. You might get from a task group hello, or group task from a hello, or who knows what. Because they're all running at the same time. They're all running asynchronously. And so they'll complete in their own order. We don't know what order they're going to run in. That's where you're in race condition territory. The chance of getting hello from a task group are pretty darn slim. And so, chances are you don't want to do that. That's a complex way of thinking for your brain. Try and order things and then get it exactly right. It's just not going to work. It's just not going to work. And there's actually a better way of doing this. I'll show you later on, using async let bindings instead. But the point is that all these tasks in the group, their goal will get to here's one value, here's another value, here's another value, As a group, you then resolve all those values into a single value and send it back somehow. Now, if inside your task group you are running throwing functions, then you don't say with task group. Instead, you say with throwing task group. And now you've got to use try await, do stuff. We can't just do await anymore. It's for try await because it might have to be handled somewhere inside here, right? And for example, we might say, so again, try await here. I want to get an array of lots of values from all my weather reports. So I might say, for example, down here, let's get rid of this line here. Let's say func print all weather readings is async. And then I'll do print calculating average weather. Let result equals try await. Now with throwing slow task group of array of double dot self. So each one of the tasks in my group will return an array of doubles. My group comes in, I'll pass a string back, and inside here I'll say add asynchronously try await get weather, come on laptop, you can do it, readings for London. That returns the array of doubles for the weather readings for London. So that task will get back an array of doubles. I'll then say group async the same thing for Rome. And then group async the same thing for San Francisco. Like that. So we now have an array of doubles from London, an array of doubles for Rome, an array of doubles for San Francisco. And what we can now say is, I want to put those into an array of arrays. That's what we've got, realistically, an array of arrays right now. We want to try and get these things into a single array of doubles. So I'll say, let all values equals try await our group dot reduce. So I'm going to get out of our group, which is an array of doubles. So remember, London's weather readings, array of doubles. Rome, array of doubles. San Francisco, array of doubles. Together, it's an array of doubles. We can reduce that down to a regular array. So now all values will contain all numbers in one flat array. Elliot, getting a headache. Hey, I said at the beginning, if you're here at the beginning, this is hard stuff. It is hard stuff. There's no way around it. It's hard stuff. That's good. Headache, sure, it's working, sort of. Anyway, I can now get the average worldwide temperature by saying all values reduce 0 plus divided by the double form of all values.count. And finally, return overall, come on you, average temperature is average, like that. So let's break it down step by step. This thing is going to create a throwing task group, a task group that's going to throw errors inside it somehow. Each one of the tasks inside there will return an array of doubles inside there. What do you want to do with this? Well, Rome, array of doubles. London, array of doubles. San Francisco, array of doubles, and so forth. The whole group, therefore, will be not double, but an array of double, like that. We then collapse it down to a single array of all values in one single dimensional array, and then, that should be a dot here, sorry. Then sum up all those values, get the mean average, and send it back as a string. That's where we are now. So now we have inside result, this will be our string saying overall average temperature is some number. And as Mark's asking, what if these things throw? Well, I haven't made my throwing task group handle those errors. I haven't asked to handle them. I want to handle that somewhere else. You could handle it internally if you want to. It's down to you. It will just cancel the other tasks and similar. In our case, though, I want to handle that outside the task group, like this. And I can now say, no matter what goes wrong here, catch it all in one place. I'll just do print error calculating data, like that. So I've caught the errors from the whole thing in one place externally. So we've got each of these calls to async inside the group again, happening here. If the group succeeds, this will all run, return back the string, put it into result, and we can now print it out. We could say print done with result. But if it throws an error, reading the values out, any point these things throw an error, we don't want to handle that. We bubble it up to outside the task group to handle it there instead. So it's a great way to do lots of complex work and wait for it all to finish fully before combining them somehow. Now, if you want to, you can say to your task group, actually, just bail out. Just give up. You can just say cancel all at any point. Or you can say, when I'm adding work, don't just add the work, only add the work async unless cancelled. So don't add the work if I am cancelled. So you've got a lot of fine-grained control over your code. Sam asks, when would you use this? Like if you had lots of work to do, fetch some data, fetch some other data, fetch third data, load an image, decode it, add this. We've got lots of complex pieces of work, but they've all got to be joined together somehow. Then you'd want to do this kind of work. For example, 3 different pieces of network data, 3 different images being loaded or rendered, 3 different whatever it is you're working with happening, but wait for them all to finish, then combine them and use them somehow. It's extremely common actually in applications. However, there is an easier way to do this. This is the really careful, structured approach. It's a beautiful way to get exact control over your functionality. There is an easier way. And I'm going to delete all this code because tons of code already. Sorry. I type a lot. Let's go ahead and just zap all this code for now. There you go. All goes away. I'm going to say I want to have multiple pieces of data for my user. I'm going to say that there's some user data, has a username, string, and has some friends, a string array, and a high scores table for the game they're playing, which is an int array. Like this. And now in my code, I'm going to write 3 separate functions that will load those pieces of data. The username might come from the keychain. The friends might come from a network request. The high scores might come from another network request or from persistent storage or who knows where. They're loaded somehow. I don't really care how. So I'll say func get user is async returns a string. What's it going to return? It'll just turn Taylor Swift for now, okay? But obviously in a real thing, fetch from the internet, decode some JSON, I don't want to do some complex work here to load your user data somehow. GraphQL, cool, there you go. That's cool, kids. Then we'll say func get high scores. Again, async returns an int array. Again, you do some complex work here to get values. I'll send the value back immediately. The answer is I'll do 42, 23, 16, 15, 8, and 4. Like that. Our third function, func get friends, is async, returns an array of strings. And I'm going to send back hard-coded string of Eric, Maeve, and then Otis. That. Again, it's async. Do whatever you want. Await some URL session call, download, decode, whatever you want to. It's your code here to do complex work. I've hard-coded 3 values here. Now, if we want to make an instance of our user data, we need to have the username and the friends and the high scores in order to work correctly. And they all come from 3 different places. Persistent storage, keychain, internet, I don't really care where, all different places. We want to stitch them together somehow into a single user. And we can do that by saying func print user details async, then async let username equals get user. And async let scores equals get high scores. High scores. Then async let friends equals get friends. Like that. So go ahead and start waiting for these things to happen. Do this work now. Now it's whinging at me because I haven't enabled experimental content. Well, that was another option there, wasn't it? Maybe turn on the forums perhaps. One of the other flags we can switch on. Enable, that's the one. Enable experimental concurrency. Love it. Let's do that, shall we? Experimental sounds great. Build settings and Swift flags we enable, I think. Swift. There we go. Let's just poke it on in there so it doesn't warm me too much. Boom. Is it X front end? It is. Sorry, today's the X front end that as well. X front end that as well. Otherwise, I'd be very unhappy. There we go. Okay, in theory, that'll be happier. So we're saying async let get user, async let get high score, let's get friends 3 times here. And this only works if you are already in an async context. So you can only do this if you are currently doing async work here. And now you can go ahead and start using them. You can say, I want to read them back in, do some work, whatever you want to, and pull them together however you need to. I might say, let my combined user be await user data. Come on, you can do it. User data, co-completion, not happening, cool. Name, oh, there you are, it's happening now. Fine, it's a bit slow to the game, next code. User data, come on, come on. No, there we go. Okay, username. Friends is friends, friends is friends, and high scores is high scores. And then I do print, hello, my name is user.name. And I have user.friends.count friends. Boom. So all 3 of these functions will be running, fetching the data from wherever you want to around the world, device, I don't know where, around the world, and we stitch them all together. Sorry, scores here, not high scores. We stitch them all together with a single await call. Await all 3 of those things to finish and return a value. And what do I call it? Username, sorry. Stitch them all together into a single user data just by saying await. And it will do the rest of the work for us. It's really, really powerful stuff. Even better, if these things happen to be throwing, then you have to say try only when you start using it. You say async let do the work and then push back the try handling until you try and actually read the value back out again. So you can handle the errors later on when you actually need the value out if you want to. So, for example, again, lots of examples here. Love example code. If we had don't do this. If we had an asynchronous Fibonacci number sequence generator, I made it clear, don't do this. It's a bad idea, and you'll see why in a second. It is hopelessly naive. We might say enum number error returns an error. Case out of range. Don't support too many here, otherwise Mac will really, really hard freeze up. We'll say in here, I want to do Fibonacci, again, Fibonacci of number, int, async throws, an int. And this is going to call itself recursively using async await, async let every single time. And it is not efficient at all, but you get the idea. If number is less than 0 or number is greater than 22, so you can't go negative, obviously it doesn't work. Can't go too big, my Mac will freeze up. I'll do throw number error dot out of range. If we're still here, I'll say if number is less than 2, brilliant, return number, because 0 and 1 happen to be 0 and 1. Otherwise, we'll use async let to call Fibonacci of our number -2, and then async let second equals Fibonacci a Fibonacci of our number -1, and return try await first plus second. Like that. So we're calling ourselves recursively without memoization using async. This is going to be deeply inefficient, right? You really don't want to do this. So yeah, please don't. But the point is that we can handle calling asynchronous throwing functions here very, very easily if you want to, and then just handle that in one place. Both of these two things can throw. We only have to handle a throwing in one place. You don't say async let try, async let try again and again and again. You kind of push it back to when it's actually needed, which is really, really nice. So at this point, I've been talking now for quite a long time. An hour and 40 minutes, right? And we're only about, believe it or not, about halfway through the changes in Swift 5.5. I mean, it is just vast. So many changes in one language update. And they're complex. Like I said, they're complicated changes. Do you have the brain power for more? If you do, I will happily plow on in with even more Swift 5.5 because there's so much more to come, including things like actors and CG float, double bridging, and more. In the meantime, I've got my caffeine-free Diet Coke. Other colas are available. I will pour a glass of that for myself so you can hear me belching comically down the microphone. Sorry, I do need a drink. I've been talking quite a long time now. My mouth's getting quite dry. Well, you're still here. You are clearly a glutton for punishment. You had your chance to run away. Yeah, Elliot, you're fried. You try teaching it. The thing is, tomorrow I want to do things new in UIKit because there's stacks and stacks of things changing in UIKit as well. So, yeah, I mean, I can just keep on talking. Anyway, the point is, we're only a fraction of the way through, and there's still much more to come because Swift 5.5 is really changing a huge amount. All right, mostly folks saying yes, carry on. So I'll just blindly continue and hope for the best. Okay, let's go ahead and clean up some code. It's getting really messy now. There we go, much better. Okay, Swift 5.5 has a lovely way to adapt old style completion handler code to new style async await style code. Now for Objective-C, all of UIKit, all of SpriteKit, all of you name it kit behind the scenes, it will automatically do some really cool bridging. It'll take completion handler Objective-C code and bridge it across to async Swift functions. And that's clever. But what's like, wow, is it'll do the reverse as well. And so if you write an async Swift function, it'll bridge it into Objective-C completion handler code automatically. It's just amazing. But there are many times when you have completion handler code you want to leave alone. Like it's not yours, it's someone else's code, or it's complicated code that's used in lots of places. You don't want to touch it right now, you've got other problems to think about. And in this case, you can do a little bit of bridging using continuations. So for example, if I had a function called fetch latest news, which is completion handler escaping, takes an array of strings, and then returns void. This will do some work. Go to the internet, download some stuff, yada, 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 send back the values. I'll just do dispatch queue.main.async and call a completion handler with Swift 5.5 released, and Apple acquires Apollo. For Reddit, that is, not the GraphQL company. Not true, by the way. Sorry, Christian. That's a fairly traditional sort of completion handler thing. I expect we're given an array of strings at some point and return nothing at all to send back that value. Let's assume that is your function, right? And that's either used in lots of places you don't want to touch right now, or it's someone else's function you can't change very easily, but you want to use a new fancy pants async await in Swift 5.5. You don't have completion handlers anymore, you want async await. And so Swift gives us the idea of continuations. the ability to make a little bridge to adapt an old API to a new API from completion handlers to asynchronous functions. And we can do that by saying, I'm going to make a little wrapper called, helpfully, func fetch latest news. This takes no parameters now because it's going to be asynchronous, which means it will return its array of strings directly. No more calling the completion handler to send it back directly to an asynchronous function. But we want this thing to call fetch latest news with a completion handler, and that's where these continuations come in. We can say await with a checked continuation, this thing. I want to pass this thing in some code to run, and it'll give me a continuation, which we're going to call when we're ready. Inside there, we'll call our old API. We'll say, I want to call fetch latest news with some items coming in. And inside that, continuation dot resume returning those items. Like that. So we're telling it, yes, take our exact same API we'd have used before, fetch latest news with a completion handler closure at the end, but wrap around it this continuation. So we end up with a truly async function in Swift 5.5's asynchronous world. And we now get all the new async await behavior without having to change our original function. We just put a little wrapper, a little shim to temporarily bridge us over to where we want to be. So we can now have something like func print the news is async, and then do let items equals await fetch latest news, and then for item in items print item, like that, and it'll do it all for us. So we've bridged print news needs parens here. We've bridged the old API style to an async await style instead, without having to rewrite our code. It's really, really nice. There is one thing there I missed up I wanted to show you, which is really cool. It's in Xcode 13. If you say for item, boom, it creates a singular version for you. So I just type literally for IT. It does the rest. It says, oh, items is plural, singular is item. You want for item and items. And I did. Brilliant. Great, great Xcode feature. Really nice Xcode 13 improvement. So these are continuations. Bridges between the old world and the new world. They're really, really nice. But it's called a checked continuation, because Swift's going to check things on our behalf at runtime. It'll make sure we aren't getting things wrong, because you've got to do something with the continuation. You've got to say, hey, here's my finished value. I'm done. Carry on working. Here's my value, like I'm doing in line 19 right here. If you forget that, you've got a leak. You've got this thing staying alive somewhere without returning. You've wasted the data. Your code's not working the way you expect it. And so if you do that, Swift's going to say, hey, no, there's an error here, or a warning. This is a bad idea. Make sure you always use your continuation. Similarly, if I had some logic here, and then call resume again, it's a serious problem. I'm trying to send values back twice. Isn't allowed. And so Swift, with a checked continuation, will actually have an error. It'll go, bang, don't do that. Stupid idea. You know, it's an illegal operation. Okay, the dogs have now arrived for Lord Mooch. Took you a while, eh, dogs? Took you, what, half an hour? Is it beauty sleep time, perhaps? Come on. You get a comic relief break. Come on, quick shot. Good go. One. Where's Luna gone? Luna? Where's the other dog? Oh, there she is. Come on, quick shot. Come on. Up. Good dog. Yeah. All right. So Swift's going to check these things for you. Are you using them correctly? Are you calling them exactly only once ever? Not twice, not nonce, no, never. Right? And so it'll check them for you. Now, there is a cost to doing that. It's doing some extra work for us behind the scenes. And as a result, if you're super sure your code is correct and you want to avoid that runtime cost, you can say not checked continuation, but unsafe continuation. And this will no longer do those runtime checks on your behalf. You can call it twice. You can forget to call it, and good luck. I mean, it's your own fault, quite frankly. The nice thing is, they're both called in exactly the same way. The code with unsafe or with checked, the same way, return the value, same parameters going in and so forth. And so you can switch across from one to the other very, very easily. And so I expect most of us will use checked most of the time. A handful of folks will go check, 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 checked, ready for release now, unsafe. They want the extra little performance boost just to make absolutely sure. So that is continuations. A lovely feature to bridge the old world of completion handlers and the new asynchronous world. Next up, this is where things get interesting. Swift 5.5 introduces the concept of actors, which is used in a handful of other languages, and I've used none of them. I've used none of the other languages, Akka and similar. None of them. And helpfully, the Swift team appear to have hired from Akka, say, hey, do you want to come over here and have another go at doing our stuff? And as a result, there's been some wonderful work toward actors, and the implementation is really, really nice. What they are... Sorry, my dog's got hiccups now. Oh. Eat your treats slower next time. Actors are effectively classes, right? We can create them as classes, but they are designed, baked in fundamentally to be safe to use in concurrent environments. So you cannot make a wide variety of common mistakes with them. And even though Swift 5.5 introduces a range of gigantic features, it's not Swift 6. It's Swift 5.5. I don't know why. I expect it's why, because it's a non-source breaking change. It's Ben Sherman. Hi, Ben. How's it going? NS Screencast. Go and check him out at nscreencast.com. Swift 6, I believe, is more likely to introduce source breaking changes because of the way they handle this isolation of data. 5.5 does not. And that's why I think it's called 5.5 rather than 6. But they're really important. Yes, there we go. Conrad, Kotoso, I think he called himself on Twitter, who did come from Akka. And I haven't seen many talks yet, which is a shame. I was hoping to see him in a talk. I think he's based in Japan, which is probably why I didn't see any talks. Anyway, actors. They're like simplified classes that are safe for concurrent uses. And it's really, really powerful here because Swift at the compiler level will make sure you don't share mutable state in your actors automatically. And it helps eliminate a wide variety of bugs literally at compile time. It's absolutely beautiful. As an example, let's think of a simple class example. There's someone who likes collecting cards. Here. Like this. A collector of cards. And they've got a deck of cards here, which is a set of string. Right? That's the cards they're collecting right now. And there's an initializer with deck set string. And I'll just do self.deck equals deck. And what this person is going to want to do is have a transfer method to receive a card coming in and a send method to send a card to somebody else. They're collecting cards, they've got a trading card, meet another collector, send from A to B, and so forth. So I'll say we've got a transfer method, which takes a card string and as deck.insert that card. We're also going to have a send method to send a card to another collector. So I'll say func send a card, which card is selected, to a person, another risky collector, and returns bool. Now, if our deck contains that selected card, brilliant. If it doesn't, though, send back false straight away. We can't do the trade, we haven't got the card you asked for. If we're here, we have got the card, we can do something with it. We will first remove that card from our set. We'll then call person.transferCard, send that card to the other collector, and send back true. And this is how we can have a simple card collector. And I've called it risky because it is risky. There are all sorts of problems with this. Now, in a simple, single-threaded environment, this code's basically safe. We check, do we own the card? Yes, we do. Remove the card. Transfer it to the other collector, say it all worked. Brilliant. But in a multi-threaded environment, there's multiple things running in parallel right now, maybe multiple trades happening right now. We have a race condition happening right here, or potential race condition at least. And that's again where two parts of the code, we're trying to compete to see which one completes fastest, and it means separate parts of our code will affect the actual results we get. Think about it. We call send to a person twice on two different threads with the same data. The first thread, reverse view, right? First thread. Yeah, first thread. Left to right. The first thread here goes, do I have the card? Yeah, got the card. Brilliant. It goes to this line of code here. It then, the second thread goes, do I have the card? Yeah, I got the card. Brilliant. It goes to here. So they're both on line 24. First thread removes the card. Oops. Transfers the card to the other player. The second thread attempts to remove the card, can't because it isn't there anymore, but so silently fails, and then transfers it anyway to the other person. So we've got a race condition happening here. They can both try and compete to see which one wins. And they both have the possibility of getting different answers depending on the speed they run. If contains runs at the same time, one might fail, one might succeed, they both might succeed, who knows what. It's a complete mess. In this situation, what will happen is we'll transfer the card twice. We'll actually create a new card, right? We've removed it once, transferred it twice from our data. And if this is a particularly valuable card, I believe Black Lotus from Magic the Gathering, for example, is a very, very valuable card, then you've got a major problem. And of course, anything, the classic example is bank accounts. Same thing there. You don't want to have money being invented. It's a bad idea. Actors solve this problem by introducing the idea of actor isolation. All the stored properties and all the methods on an actor cannot be read from outside the actor unless they are performed asynchronously. And the properties cannot be written to at all. Just don't do it, right? And the asynchronicity, the async behavior, isn't their performance. That's not its goal. The point is how it handles it. Swift will pass the request, please transfer the stuff, whatever it is, please send a card. It'll pass that into a little queue, like a message, and say, go ahead and do this when you're ready. And the actor will ensure that only one piece of information is being processed at any given time. Only one thread is using its data at any given time, automatically. We haven't got to worry about it at all. It's really, really nice. And so we can say this is no longer a class, it is an actor. I'll call this thing a safe collector. This is much, much safer. It can't go wrong anymore, right? So we have down low. No, it wouldn't crash. You can remove this thing from set and it wouldn't do anything at all. So no, it wouldn't crash. So we now have this thing, and it's telling us straight away, wait a minute, you're trying to transfer this on an actor isolated method. You can't do that. You cannot do that unless you are calling it on yourself. An actor can do what it likes to itself, but to do it on another actor, we've got to make this whole thing asynchronous. We cannot do it synchronously anymore. So this thing here is an async function, and we're going to await transferring the card to the other safe collector, like that. So we've made a handful of tiny, tiny changes here. We've got this new keyword here, actor. This is what in fancy pants compiler land is called a concrete nominal type. We have structs, we have enums, we have classes, we now have actors. They're a top level type like that. When we want to work with data from an actor, we have to be in async context. So our send method has to be marked async. Plus, the transfer method must be marked with await. We have to call with await. This won't run immediately, necessarily. It might be immediate, but it might also take some time because some other thread's doing some work in the other actor right now. So an actor can use its own data as much as it wants to. It can read my value, deck remove here, deck contains here. This is all fine. That's my deck. This is all good. But when I want to talk to a different actor, that's when it goes asynchronous. And with those simple changes, Swift will ensure that all actor isolated state will never be read concurrently. Never be read from like 3 things happening at the same time. Oops. Let's just ban House of Pain because they're clearly a chump. Anyway, anything like that remotely has to be done asynchronously. That's how it works, right? It's another person's data. We can't just read it directly. And it's done at compile time. It wouldn't let me call that directly. It knew this is a bad idea. You've got to use await here automatically. So the compiler is checking it all for us, which is fantastic. Now, like I said, they're basically simplified classes. Sam, I don't want Instagram. What do I use Instagram for? Pictures of code? No, I'm on Twitter. Get to use Twitter, man. They are both reference types. That's intentional. They're designed to be shared in your program. To be shared state. That's the point of these things. But they're safe shared state, unlike classes with the unsafe shared state. But they can have methods and properties, initializers, subscripts, and more. They have all the same regular Swifty functionality that classes might have. Except they cannot be subclassed. You can't have inherited classes and actors down the line. At least not yet. They can, if you want to, conform to protocols. They can be generic. Plus, if you have methods that are static or properties that are static, they have no idea of self. Therefore, there's no isolation. They're just pure functions as far as I'm concerned. Why isn't transfer method marked as async? It's automatically going to be async. That's the point of the actors. Who was it? Eternum. But it's the point of the actors is using any of these things remotely makes them async. It just seems rather annoying to having to put async everywhere. Because remember, the actor can call its own functions synchronously. That's fine. We don't await those. Only other things have to be called with await. I would say I did see some discussion that maybe they're thinking about possibly adding actor inheritance in the future. It's like it's not in there now, but they're not trying to like ban it, right? So there's no need for final. There's no convenience required initializers and nonsense, no overriding. That's all gone away, right? They're much simpler beasts at this point. And helpfully also, all actors conform to a new protocol called actor, which is good because you can actually use that to restrict parts of your code. You can say, actually, this function here takes some kind of actor, which is cool. The best way I've heard to explain how actors differ from classes is this. Actors pass messages, not memory. So they say, hey, please do this, please, as opposed to sort of poking around in properties and strings, integers, and so forth. And so rather than you sort of nudging around and changing things or calling their functions directly, they say, please give me your value. Please call this method, whatever. And the Swift runtime handles it all for us. Pavel Power asks, are they reference types? Yes, they are. That's the point. They're designed to be shared as a point of actors. Okay, so that's actors in a nutshell, but it goes further than that because Swift 5.5 introduces the idea of global actors, actors that are available anywhere you need them using special markup. Now, in theory, you can make your own global actor if you want to. In practice, honestly, I think we're all going to use the one built-in shared example, which is @main actor. This thing here is absolutely brilliant. You can mark properties, methods, or whole types with @main actor, and Swift will make sure for us out of the box whenever you call that method, for example, or any of that type, it'll run on the main thread. It's really, really nice. For example, we might have said there is a sort of classic example of something you want in the main thread. If I had an old data controller class, and I want to save stuff here. We don't want to have multiple saves overlapping at the same time. It's a bad idea. So we want to make sure we're on the main thread when we call this function. We would say guard thread.isMainThread, else return false. So refuse to even work unless we're on the main thread right now. And then we'll do print saving data and then return true. So you've saved data to disk, basically. The kind of thing you don't want to have being called several times at the same time, because it's a disaster from corruption everywhere, right? Make sure on the main thread and then write it out. That works. But with this new main actor, we can actually make that whole code much, much simpler. We can say instead, there is a new class, new data controller, and this thing is going to be at main actor func save. I'll do print saving data. And that's it. It will make sure when you call save from anywhere in your program, it will always happen on the main thread. No more work required. If you want to say, actually, this whole class is going to be a main actor class, great. Everything inside there will now always be called in the main thread. It's automatic. Now, obviously, again, this is an actor behind the scenes doing some work for us. What's going to be required is when you want to call save on your instance, you've got to use await. Push this message into the message box, please save on the main actor. It'll do its work on the main thread eventually and say, yes, I'm done. But you've got to wait for it to come back automatically. And this main actor, I'm not sure if we'll see it perhaps if this is going to work. No. The main actor is actually a struct. The main actor struct. It uses a global actor keyword to make it an attribute, to make it into one of these fancy at main actor things, but it's a struct underneath the hood. It's helpful because if you want to, you can actually call main actor.run. So if you had some work here, you might say main actor slow motion dot run some code. And that code will be run on the main actor, on the main thread, right? Sorry, you got to await that, obviously. Here. So it will make the whole thing. You see how it spreads so easily, can't you? The point is that you can go ahead and call that on the main actor, and it will do it automatically if you want to. And it's more or less dispatch queue.main.async, right? It's the same thing as far as I can tell. I see no difference there, quite frankly, at all. Do this work on the main thread somehow, just in a more convenient way. Whew, okay, let's think now. So we've covered actors, and they're not complicated, but we'll have to see how they pan out in actual practice and use. There's a bunch of improvements for SwiftUI, which is really, really nice to see because it makes SwiftUI that much nicer. Jack Shavat asks, is there any advantage to wrapping a class in an actor rather than making it an actor in the first place? I don't think so. I mean, I'm still noodling around trying things out, and I think it'll take a little while for us to figure out, what the costs of these things are. But no, I would make it an actor directly. Actors seem brilliant, quite frankly. They seem very, very nice as a way to share data safely, which is cool. Anyway, SwiftUI improvements. Back into our SwiftUI example over here. Let's just clear this code a little bit. Yeah, get rid of all this junk. You can all go away. Here, go away. Go away. Nice simple code again. And then boom. Text. Hello world. And which compiler are we in? We're in the wrong one, so let's switch that again. Okay, so they've made some improvements to SwiftUI into Swift in 5.5 that benefits SwiftUI. And one of the most important one, I think, to cleaning up your code is hash if for postfix member expressions. Main actor is an actor, not a class, and actors do not support inheritance at this time, and may never will. We'll find out. Anyway, what this means is you can now use hash if to do a check and modify your code with postfix member expressions. For example, if I had text hello world in font large title, that might look really good on Mac OS, for example, but look too big on iOS. I can instead say after text #if OS Mac OS, do large title, else let's use .font.headline, end if, like that. And that's now perfectly legal. That was not possible for in Swift 5.4. If you want to, these can do wildly different things. You could say I want a large title there, but here I want, foreground color red. Honestly, it can do whatever you want to do it, all perfectly fine. And if you want to, you can even nest them. You could say I want to have, if it's Mac OS, use large title, else if I am in debug mode, then that, else something else. Let's do foreground color secondary. There we go. So you can nest them. I wouldn't recommend it, but you could do. And that's cool. If you really wanted to annoy your teammates / have maximum job security, use whatever the heck you want. Honestly, you can do whatever you want. You could say, like in here, I'll steal this save function here. You could have said, let result equals an array of 1, 2, 3. If OS, #if OS is iOS, then I want to read .count. Else, I want to use reduce 0 plus end if. And they do completely things. What different things? Whatever you get from printing result will either be 3, the number of items in the array on iOS, but on all other platforms, it's going to add them together to make 6. So don't do that. You can do it. Doesn't mean you should do it. So please don't do that unless you really, really hate your teammates. You could even, if you wanted to, make them completely different types. And actually, that's what we're doing over here inside SwiftUI. It's all some view ultimately. We've got a font thing here or a foreground color here. You might have had, background dot ultra thin material or something like that. All sorts of customizations. They all resolve into some view with some complex type behind it, of course. So you can do that if you want to. Please don't. What can I say? Please don't do that. Bad idea. But there are more improvements to SwiftUI because one of the things that has plagued my brain since day one has now kind of been retroactively been removed, which is cool. SwiftUI has all sorts of ways to manipulate your views. If I look in here in my text, for example, I can say my text has opacity of some number, opacity of 1 or 0.9, whatever, right? And if I had a scale, I could say I want to have a scale effect of something else, and this will also be 0.9, for example. So it's slightly transparent, slightly scaled down, right? If I set up here, let my value be 0.9 and try to put that into here and here, what I have silently done is actually mixed 2 different values. If you look carefully, scale effect expects to be given a CG float. And opacity expects to be given, thank you very much for the use of completion, opacity expects to be given a double. Double and CG float are completely different types in Swift. In Objective-C, it was a type def, but in Swift, they're different types. And so you had to have, my value was explicitly a CG float here, or you'd constantly do typecast to say, okay, this one is a double, but this one here, that's a CG float. It was very, very painful. And I mean, ideally, they wouldn't have shipped CG float at all in SwiftUI. It'd be just double everywhere. That didn't happen, presumably for performance reasons. And they've done away with it. You can now mix and match the two. Now, what is not happening here is they have not gone back and retroactively added double overloads to everything. There's no scale effect that takes double. It's still a CG float behind the scenes. What's happened is that Swift recognizes these two things are basically the same, right? They are interchangeable with fractional differences, but basically the same thing. And it will silently add that for us. CG float, my value. It'll create the initializer for us with our double into CG float and also vice versa. So it'll go double CG float, double happily. It'll prefer double at every possible cost if it can, but it can go either way, which is really, really nice. Doing all that work for us. And this means you can actually just treat the two as being interchangeable. You could now say something like, let first is a CG float equal to 42. Let second be a double equal to 19. Let result equals first plus second, and then print result. And that's absolutely fine because it will automatically bridge the two by having an implicit initializer to make this CG float here into a double. That's just doing behind the scenes, basically, doing that, which is cool. That will really help with SwiftUI particularly. There's more. There's still more. Honestly, it's a packed release. They've added support at last for codables, enums, to be codable if they have associated values, which is really, really cool because before they had to be raw representable and handle it that way, it wasn't very pleasant. And now they've made much, much more flexibility and power enabled for us basically free. We could say there's an enum called weather, which is codable. It might be sunny. It might be windy with a speed of int. It might be rainy with an amount int and a chance int. And we've now got a simple case, a more complex case with one value attached, an even more complex case with two values attached. It handles them all. It'll handle any kind of data you want to. You can now say, I want to have like a forecast be an array of weather, and I'll just pass in all of, let's do, it'll be sunny, then windy with speed 10, then sunny again, then it's going to rain for a while, let's do amount 5, chance 50, like that. A whole array of weather here. I can then put that straight into JSON and bring it back from JSON into enum values. I could say let result equals try JSON encoder dot encode that forecast. That's now as data. I can then get into a string to prove it all works. We'll do let JSON string equals string decoding that result as UTF-8.self. And then print JSON string. If it goes wrong, we'll just do print encoding error. And do error.localized description. Boom. And that'll do the whole work for us. Let's find out. If I press build and run, I can get rid of most of this junk. In fact, not using async work anymore, are we? Nope. Let's run it back, see how it looks. It's planning how to build my 34 lines of Swift code. Come on, you can run it. I've got faith in you. Wilfried looks forward to Apple open sourcing SwiftUI at some point. I wouldn't get your hopes up. I wouldn't do it if I were them. I still have the concurrency noodling enabled. I probably have to take that out again. Let's just delete all these values here, maybe. So I can get my thing being happy again. Come on. Have another go at building my code, please. Be nice. Play nicely. Run again. There we go. So that's the string it outputs as JSON. So you can see that sun has no values, wind has speed 10, sun has no values, rain amount, It's all there. We can read it back in and make enum stuff for us here. And it's actually behind the scenes doing all sorts of work for us. It's making multiple coding key enums to handle the nesting structure for us. It's doing a lot of work in hardly any code. It's really, really nice. And honestly, folks, there's still more. There's still more. You can now use lazy in local contexts. You could say, I want to have lazy var greeting equals, print greeting to Paul, and it'll call a function print greeting to string. Come on, string print in print greeting, and then return hello to. I've made it lazy, so it won't actually call print greeting until it's required. You can go ahead and do, print I'm before lazy, print I'm after lazy, and then print greeting at that point, and it'll only call the lazy function at that point. So it should print before lazy, after lazy, and then int print greeting, in theory, and then our hello message. Let's find out. I'll press Command R to build and run. Exciting. There we go. So it pushes the work back until it's needed. And you might think, well, why is that needed? It's one of those things that you can basically just set up the work here, make this thing at the beginning, but don't do the actual work. Go ahead and do some complex logic. Oh, it's really needed. Now print the greeting out, at which point it'll call print greeting and do the work behind the scenes. But maybe you never have to do that work. You can save it entirely, which is really, really nice. And there's more. There's even more. It's just packed with information here. We can now use property wrappers inside function closure parameters. You can now say this parameter to a function has a property wrapper attached to it automatically to do some extra work, which is really cool. For example, I could say I want to have a function called setScore. I'll call it 1 to score int. I'll do print setting score to score. And we can now go ahead and call that however we want to. Let's do set score 1 to 50. Set score 1 to minus 50. Set score 1 to 500. Whatever you want to. Now, if we said actually our score needs to be in the range of 0 through 100, nothing else makes sense. These two values here are bad. We don't want those to be used anymore. We want to clamp them in the range 0 to 100. And that's where property wrappers come in. We can make a really simple property wrapper. Let's say, actually here's fine. At property wrapper. Here, oops, like that one. Struct, I'll call it clamped to some kind of comparable data. Our wrapped value is that comparable data, that t even. There's an initializer with the wrapped value of type t and a range to work with. So the range 0 to 100, for example. Closed range, sorry, closed. There you go. Inside here, I'll say our wrapped value is, and we want to make sure we clamp it between inside that range. Don't go below the minimum, don't go above the maximum. That's done by saying min and max the wrapped value. So range.lower bound, comma, range.upper bound. So clamp it in that range correctly. And that is now a fully working property wrapper. We can have a new function down here called setScore2. Again, using toScoreInt. Again, doing print setting score to that score. But now we want to apply our clamped property wrapper to that particular value coming in. So we can say setScore2 at clamped range 0 to 100 to score. Like that. Do not let our value go outside that range. And now we call setScore1, we'll call 2, 2, and 2. And press Command R. It should make sure our values stay 50, 0, 100. Boom. Exactly right. So we're forcing our values into the right format here without having to write any extra code inside our function. It's a really, really nice way of thinking and reusing functionality. Write it once and then forget about it. Now this wrapper, clamped, is obviously simple because it's immutable. We don't want to handle updates and so forth. It's being used only for parameters coming in. But you can make your wrappers as complex as you want to, and it'll carry on working. It's really, really good. Paul, any change on decoding unknown future types? Kelvin, not that I know of. Sorry. Okay. There's still more changes, folks, but they get increasingly obscure. That is the main set, and that's been 2.5 hours. 2.5 hours. Whew. Of me talking to myself with my dogs, eating treats, and you very kindly sitting through it. We've covered stacks and stacks of new Swift 5.5 features. I hope you're keen to start using them. I know it's a lot. Like I said at the beginning, it is a lot. There's lots and lots to get into your head. Concurrency, task groups, tasks, priorities, actors, and more. It is hard. So if you're sitting here thinking, wow, my brain hurts. Okay, it's okay. It takes time to squeeze these things into your brain, and maybe just practice. Try them out yourself, see what you think, see how it fits into your code. I think tomorrow I saw a talk from Ben Cohen saying he's going to be upgrading an existing app to use these concurrency features. You'll see it in practice there, old and new, for a whole WWDC talk there. So it is hard. Don't be too hard on yourself if you find it hard, because it is difficult to understand. So give it time. Anyway, if you enjoyed the video, I make lots more videos like this one teaching folks Swift, Swift UI, and more completely free. So please subscribe to the channel, leave a like, leave a nice comment below, and share the video with your friends. It means a lot to me. It really encourages me. It makes me want to make more videos like this one. Very least you can do is hit like and subscribe, right? It's not too hard to do. It's free to do that. If you have any questions, you can grab me on Twitter. I'm there as Two Straws, TWO Straws. And in the bottom left corner of your screen, you should see hackingwithswift.com/offers. That's there for a reason, because right now I've got a half price sale on all my books and bundles. So you want to go and learn Swift efficiently and now for less, go ahead, check out that URL and you'll save big money. Anyway, there's still 3 more days of WWDC 21 to go. I hope you enjoy it, make the most of it, go to the labs, go to the lounges, ask questions, get involved. Check out wwdc.community. There's lots of great things happening, and I hope you enjoy the rest of the event. Take care, folks.